Day 554 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1611, minimum 1-bit operations to make integer 0. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out the link in the description so you can get you some. Now let's see what the question says. Given an integer n, you must transform it into 0 using the following operations any number of times. Change the rightmost 0th or the 0th bit in the binary representation of n, or change the ith bit in the binary representation of n if I minus 1th bit is set to 1 and the I minus 2th bit is set to 0 through 0th bits are set to 0. Return the minimum number of operations to transform n into 0. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, before we get into these examples, let's go over what these rules actually mean, right? So we can change the rightmost or the 0th bit in the representation of n, right? So the rightmost bit, say this is the rightmost bit, or the 0th bit, the same thing. The rightmost bit is the 0th bit, right? So we can either change it to 1 or 0. There's only two options, right? So we can change it to whatever we want. We can either change it to a 1 or 0 if it's the rightmost bit, right? That's rule number 1. Rule number 2 is a little bit more challenging, but once you get it, then it's pretty simple, right? So rule number 2, we can only change the bit if. So we can only change this bit right here if the bit next to it, or the I minus 1 bit, is set to 1, and then all the other bits from I minus 2 to 0 to the 0 bit to the rightmost bit, right, is 0, right? So we would be able to change this bit right here because the I minus 1 bit, and also I want to point out when we're dealing with bits, when we say I minus 1, we're moving to the right. So this would be I minus 1 and this would be 0. Whereas within an array, this would be 0, right? And then if this was I, then this would be I minus 1 to the left. But with bits, we're going in the opposite direction. So this is the 0th bit, the rightmost bit. And if this is I, then I minus 1 would be this bit, and I minus 2 would be this bit, all the way up to the 0th bit, right? So for the second requirement, we need the I minus, if this right here, if this one is I, we need the I minus 1 bit to be 1, which would be this bit. And then we need all other bits, I minus 2 all the way up to the 0th bit, need to be zeros for us to be able to change this bit right here. So now that we understand the requirements, let's take a look at example 1, right? Where so we can make it make sense a little bit more. So in example 1, let me get rid of this. In example 1, we have our input 3, our output is 2 because it took 2 operations. It says, the explanation says the binary representation of 3 is 1, 1. So let's just put this 1, 1 up here. Boom. Then it says we're going to use the second operation. So we're going to change this 1 to 0 using the second operation since the 0th bit is 1. So in this case, they're saying if there are no other zeros or there are no other bits after this I minus 1 bit, then we don't have to worry about it as long as this I minus 1 bit is set to 1. So in this case it is. So since this is I and I minus 1 is set to 1, then we could change this bit right here to 0. Boom. So that took one operation, and that's how we got this 0, 1. Then now that we have 0, 1, we could change this rightmost bit, right? Because now 1 is the rightmost bit, and that we could change that with the first operation because it says we could change the rightmost bit in the binary representation. So since this 1 is the rightmost bit, we could change it, and there's only one way we can change it. It can either be a 1 or a 0. So if it's a 1 now, when we change it, now it's a 0, and now everything is a 0, and we were able to do that in 2 operations. So just in case that didn't make sense to y'all, let's take a look at example 2. Example 2 hopefully will make a little bit more sense because there's more numbers, and there's actually a 0 after the 11. So when we do operation 2, it'll make a little bit more sense. So in example 2, input n equals 6. So the binary representation of 6 is 110. So let's put that up here. Boom, 110. Then the output is 4 because it took 4 operations. Let's go through those operations. So it says first, we changed this first bit right here, the leftmost bit. We changed this bit with the second operation, since the first bit is 1 and then the 0th bit through the 0th bit are 0. So in this case, this second operation works completely, whereas in this first example, we didn't really have the extra zeros at the end, so it may have been confusing, but this time we have the zeros at the end, so it should make more sense. So let's go through it. We want to change this bit right here. So in order to change this bit right here with operation 2, we need to make sure that the ith minus 1 bit is set to 1. So remember, we're going to the right when we're dealing with bits. So let's check. That's a 1. So let's check if the I, or this, excuse me, this is I. So let's check if the I minus 1 bit is set to 1. This is I minus 1, and it is set to 1. So it fits this first requirement right here. Boom, for requirement 2 or rule 2. So let's see if it fits this second requirement, because it says and I minus 2 through the 0th bit are set to 0. So this right here is I minus 2. If this is I, then this right here is I minus 2, and it's set to 0 like it's supposed to be. So since if these two fit the requirements, that means we're allowed to change this bit. And once again, we can only change it one of two ways. If it's a 1, we can only change it to 0, and if it's a 0, we can only change it to 1. In this case, we're changing it to 0, so now we are left with 0, 1, 0. Boom. Now the second operation that we're going to do is, so now it says 0, 1, 0. We're going to change 0, 1, 0 to 0, 1, 1 with the first operation, right? So because we're going to need to do that in order to change this bit. Right now, we can't change this bit because it's not the rightmost bit, and it doesn't have a 1 next to it in I minus 1, right? It doesn't. We can't use rule number 2 right now with this bit, because when we go to the right of it, it's a 0. We need it to be a 1 in order to complete rule number 2. So what do? We're going to change this bit to a 1 using the first operation. So boom, after we use the first operation on this bit and change it to a 1, boom, now we're left with 011, but now we're able to change this bit because now there's a 1 I minus 1 or 1 to the right of it, which now allows us to change this bit. Boom. So after we do this with the first operation, remember now that's 2 operations completed, these 2 right here. Now we need to change this 011, right? So we're going to focus on this 1 first because we need it to fit the requirement. So now we could change this 1 because the I minus 1 bit is set to 1, and then similarly to example 1, we know we can change it even if 1 is the rightmost bit, or is there are no other zeros, then we can still change this 1 right here. So boom, we're going to change that 1 to 0. And now we're left with 0, 1, 1 with the second operation, since the 0th bit is 1. Boom. And now this 1 is the rightmost bit, so we can change it again. And now we change it 0 using the first operation because it was the rightmost bit. So we're allowed to do that. And in total, that took 4 operations. So that's how we got the output of 4. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. So let's get into it. Now, the first thing we're going to do is we're going to initialize our result counter, right? So we need a place to store this output and keep count. So we need to initialize that. So we're just going to declare a variable called answer, and we'll set that equal to 0 to start. Boom. Then we're going to start with the bit mask pointing to the least significant bit. So we're just going to declare a variable called mask and set that equal to 1. Boom. Then we're going to iterate over each bit position until the mask exceeds n. So we're going to say while mask is less than or equal to n, then we can open up the brackets, and we're going to check if the current bit in n is set. So we're going to say if n and one and sign bitwise and mask sorry y'all, mask, exclamation point equals 0. So if it does not equal 0, then if the current bit is 1, then the pattern represents the total number of operations required to toggle all bits up to this position, or like reaching a gray code boundary. So we're going to say answer equals, open up the parentheses, mask times 2 minus 1, and then subtracting the current answer effectively mirrors the count around that boundary, accounting for the gray code sequence property. So we're going to come right here and we're going to say minus answer. Boom. Now we need to move the bit mask to the next higher bit, or shift left by 1. So we're going to come underneath this if, and we're going to shift left by 1 by saying mask less than equal 1. Boom. Then we need to return the total minimum operations required to reduce n to 0 by coming underneath this, and all we need to do is say return answer, y'all. Boom, that should be all she wrote. Let's give it a run before we submit it. Make sure it runs properly. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.